Here are a couple examples of working with the equation of a parabola. So to start out, let's find the focus of a parabola whose equation is y equals 1/2 x squared. So this is the sort of parabola that you've probably graphed before by, finding some sort of axis of symmetry, maybe plotting a point, and so on. But what we're going to do is use the correspondence between the equation of a parabola and the geometry of a parabola that we worked out. So this is a parabola that's opening up. We can tell that because the y is the one that isn't squared, and x is the one that is squared. So the version of the equation of a parabola we're going to use is this one, for a y equals x squared. Okay, and to find the focus, what we really need to find is a, because for this type of parabola, the focus, since this parabola is opening upwards, the focus is going to be on the y-axis somewhere, and the only question is, how far off of the x-axis is it? That is, since this parabola has its vertex at the origin, the distance between the vertex and the focus is what we called a, the focal distance, or focal length. So all we need to do is figure out what is a. Well, it's not immediately obvious from the equation that we have here because it's just not in the right form. Our sort of geometric equation for a parabola has x squared by itself, so let's make that happen. Let's take this equation, y equals 1/2 x squared, multiply both sides by 2 just to get that coefficient off of the left-hand side. We get 2y equals x squared. Now it's starting to look like what we want, except on this left-hand side, we want this to be 4 times some focal length times y. So I guess what we should do is, all right, we have a 2. We'd like that to be 4. So we can take the 2 that we started with, multiply it by 2 over 2, y equals x squared. So this is the same equation as what I had before because, right, this 2 over 2 is really just 1. But now I can take the 2's in the numerator, those multiply together to give us 4, times 1/2 times y equals x squared. And remember, what we were looking for was 4 times a times y equals x squared. And now we can see what y is, or see what a is. A must be 1/2. And since a is 1/2, the focus is the point 0, 1/2. All right. That's not too bad. You can see the main issue with using this geometric equation for a parabola is arranging it so that that 4 shows up. Because once you get that 4 to show up, then the focal distance is sitting right here next to the unsquared variable. Let's look at another example. Let's find the equation for a parabola whose vertex is at the origin and whose focus is at -2, 0. So just for a quick sketch of what that would look like, if the focus is at -2, then that's here. And that means the directrix must be at +2 there. The vertex is at the origin, so here's the focus, there's the vertex. And so the parabola must be going something like this. Not the most parabola-looking curve I've ever drawn. Okay, so this is the setup. Since this parabola is opening right or left, we need to use the version of the equation of a parabola that opens right or left. And that's for a x equals y squared. Remember, the unsquared variable is the direction that the parabola opens. Okay, well, remember the coordinate of the non-zero coordinate of the focus is the focal length. So this focal distance is -2. So actually we can just pop that into this equation. 4 times -2x equals y squared. So that's -8x equals y squared. And that's it. We're done. You can see as long as the vertex is at the origin, to get the equation for a parabola, all you need to know is what the focal length is, because then you just pop it in there. Notice that this focal length was negative because the focus is to the left of the vertex and not to the right. But still, we use the same equation. All right, one more example. Let's find the equation of this parabola. So it looks like this one is opening up or down. So we should use the version of the equation of a parabola that opens up or down, and that's for a y equals x squared. Remember, the unsquared variable is the direction that the parabola opens. So now we just need to figure out what a is. A is the non-zero coordinate of the focus. So this focus looks like 0, minus 4. But the focus is 0, a, so a is minus 4. Now that we know the focal length a, we can just put it into this equation. So 4 times minus 4 times y equals x squared. So this is negative 16y equals x squared. If you wanted to, you don't need to, but if you wanted to solve for y, you could. Y equals negative 1 over 16 x squared. All right, and there's the equation for this parabola.